Hey, earlier we discussed a possibility of updating transactions to contain more output values. Let's add that functionality now. And where better to start than the transaction testing file? So let's add a new block of tests for an update function within the transaction class. We have this update function and its callback. The update function is going to have the ability to add a new amount for a new recipient in an existing transaction's output map. However, the output map change can't just happen and that's it. There's other parts of the transaction to consider. For one, the remaining output for the sender wallet is going to be off if we just set a new value. So we're going to need to update to subtract that new amount from the remaining balance for the sender wallet. Next, the input signature is going to be thrown off too, because now the output map will have changed. Therefore, the input is going to have to be re-signed by the sender wallet. Okay, let's write some test scenarios that will make sure that all of these events happen. First up, we're going to have a testing scenario that says it outputs the amount to the next recipient, whoever the lucky Joe is. Cool. And this has a callback function, and nice. Next, we need to make sure the remaining balance for the sender wallet is accurate. The new amount should be subtracted from the sender wallet's balance. Without this part, the update function could be a cheeky way for the sender to sneak in some free transactions. So that wouldn't be the best situation overall for all parties involved. Let's say it subtracts the amount from the original sender wallet balance. Cool. Or rather, it's more accurate to say it subtracts the amount from the sender output amount. So that is a better testing description because in this case, it's an output amount that we're updating for the sender wallet's public key. Another thing that we need to test is that it maintains a total output that matches the input amount. So we don't want this to be thrown off. Let's say it maintains a total output value that still matches the input amount. All right, cool. And the final thing that we need to test is that it re-signs the transaction. So our test will say it re-signs the transaction. All right, awesome. To properly test the update, we're going to need a few variables. First off, to properly test that the transaction is re-signed, we'll want to keep track of the original signature. So at the top of the update method, let's have a variable where we can set the original signature. Likewise, to test that the sender output amount gets updated, we need a similar variable. We need an original sender output. Likewise, if there's a next recipient to look at, well, we need a next recipient variable. And finally, we need a next amount for this updated transaction as well. Then in the before each block, let's assign values to each of these. First up, the original signature is going to be equal to whatever is the current transaction input dot signature. And then the original sender output, likewise, is going to be whatever is in the transaction output map located under the sender wallet's dot public key. Cool. And if you look above, we do indeed have a sender wallet available for every test in this transaction scope. Next up, we have a next recipient, and this can be any string value. So how about next dash recipient? And then finally, the next amount, and let's use 50 since that should be a valid amount to update this transaction with. Cool. Now this brings us to the method at hand. We're going to call transaction update and pass in a combination of all of these values within an object. Now the first thing that we need to provide is actually the sender wallet. And this is crucial to allow the transaction to be updated with a new signature from the sender wallet. As for the next part, we're going to have a recipient to designate, and this one is going to be next recipient as well as an amount. Let's map this to the next amount that we have specified. So overall, the three fields in the object that goes into the update function is the sender wallet, the recipient, and then the amount for the updated transaction. Cool. This brings us to the first test, where we're checking that it outputs the amount to the next recipient. So let's expect that if we look at the transaction.output map and then access the value for the next recipient, that this is equal to the next amount, which is the expected value. Cool. Now we can construct an expect statement that checks that the original sender output gets that next amount subtracted as well. So let's expect that if we look at the transaction output map, and if we access sender wallet.public key, well, this should be equal to the original sender output amount minus the next amount now. So overall, this is going to be the new output for the sender wallet's public key. The original sender output, which we memoized before in the before each function, minus the next amount. So the next test checks that the overall output value matches and remains equal to the input. So it's similar but a tad more involved to the test that we have before. In this case, we're going to need to get the overall output amount by accumulating the total of the output. So to do this, we can look at all the values within the transaction output map. And then we can use the reduce function to have a callback function that helps create a total for this overall values of the transaction output map. So as the first parameter to the callback, we have a total to accumulate, as well as each individual output amount. And the result of the callback is that we want to add this output amount to the total. All right, very nice. So this should give us the overall output amount total that is contained now in the transaction. And we should expect this to equal the transaction input dot amount. So overall, we'll expect this to equal transaction dot input dot amount. And let's place this overall resulting output amount value or output total value into our expect statement. Cool. Let's place this all in one line, and then there shouldn't be a semicolon now that it's a parameter, or rather an argument to this expect function. All right, awesome. We're nearly there. Now we need to test that the transaction gets re-signed. So this one is less complex. We're going to want to look at the actual value of the transaction input dot signature. And in this case, it should not be equal to the original signature. So make sure to chain in a dot not method. So that way it says dot not dot to equal original signature. So again, make sure you have that not qualifier. All right, stupendous. Once you have all of these changes, so look up and down. If you have the describe update scope, make sure you have all of these changes over here. Once you're ready, fire npm run test in the command line if you don't have it going already. Also, as usual, pause here for the chance to implement the code yourself. Otherwise, let's go to the test. And already, the first thing that we have to do is implement this update function. So in the local transaction file, well, we're going to create that awesome update function. It just feels awesome. Then we have the sender wallet in the object that goes into update, as well as the recipient and the amount. Cool. With a save of that, we should get past the no update function errors. And the first thing that we need to do is designate an amount to the next recipient. So with that, we can access this .output map. So we'll look at the output map, and then for this new recipient, we're going to give them the amount value in the output map. Cool. This should bring us to the next test. And in this case, we need to subtract this new amount from the sender wallet's public key. So we're going to set this .output map and then sender wallet.public key to a new value. And this is going to be equal to its current value, so its current remaining balance minus the new amount. So that is the new amount for the sender wallet. And as we save this, this should get past the next test. And cool, that actually killed two birds with one stone and got the test to pass where the total output remains the same for the input amount as well. Now for the final test, which demands that the transaction be re-signed. So let's give the input object a new signature. Luckily, this functionality is already baked in the create input function. Notice that near the end, we have this line that says sender wallet.sign output map. So all we have to do is reset this.input to a new call to this.createInput. Again, we need the sender wallet to the create input field, as well as an output map. And let's enlarge this so this is visible. And then we're going to pass in this.output map now that it has been updated. And as we save this should generate a new signature for a new relevant input now that the transaction has been updated. Cool. Now, this update still isn't getting the final test case to pass, even though we've regenerated a signature. Now, it's quite odd, considering a very similar test checks that the original sender output amount has been updated. So if we've updated the output and recalled the sign method on that output, shouldn't this create a new overall signature? Well, the answer is that even though we've updated the output map, technically we haven't passed in the new data for the sender wallet to sign. The bug is that this underlying output map is still the same object. To which you might be thinking, what? Didn't the output map just get some new keys and values? Well, it did. But the answer in this lies in that it's another one of those oddities of JavaScript. JS will always treat the same object instance as equal, even if its properties have changed. So in this case, it's affecting our result for the sender wallet.sign. Luckily, there's a fix for this that we can make in our CryptoHash method. So let's explore this in more detail next.